we just saw that commercial, and the commercial said, if you're waiting on the cable guy, then you will get bored. If you get bored, then you start staring out the window. If you start staring out the window, then you see things you shouldn't see. And then all of a sudden, you're attending your own funeral as a guy named Phil Shipley, right? Those are if-then statements. That's what we're talking about today. So, get your notes out. And the great news is we already wrote all the definitions for you. Get your notes out. And all you have to write is the term and the notation. So for number 1, write down conditional. A conditional is simple. It is an if-then statement. Conditional. If-then statement. If two rays with the same endpoint form a line, then they are opposite rays. There's a geometry example. Not as fun as the DirecTV example. Okay? Okay, so you wrote down conditional. The notation for conditional is if P, then Q. Why is it P's and Q's? I don't know. Someone made that up a long time ago, but that's how we're going to write our notation here. If P, then Q. If you get bored waiting for the cable guy, then you will stare out the window. Have y'all ever read those books, If You Give a Mouse a Cookie, If You Give a Pig a Pancake, If You Give a Cat a Cupcake, If You Give a Dog a Donut? So all of those books are amazing examples for conditionals. If you give a mouse a cookie, then he'll ask for a glass of milk. If he asks for a glass of milk, then. Those are conditionals. You didn't even know you were studying geometry when you were reading those books. If, then. If I do my homework, then I'll get good grades. If I get good grades, then he'll send me to college. If I go to college, then I'll graduate and get a job. If I get a job, then I might get fired. If I get fired, then I could go bankrupt and lose everything, and that's why I didn't do my homework. Whew! That's a pretty lofty argument. Pretty good logic for not doing your homework, right? So that's what we're learning about today. We're learning about logic, and this cartoon was full of conditionals, so I just wanted to show it. All right. Now, a conditional has 2 parts. No, you're still going to have homework. That was bad logic. It was bad reasoning. Conditional has 2 parts. So this is number 2 and number 3. Number 2, the vocab word is hypothesis. You've heard that word in science before. You always make a hypothesis before conducting an experiment, right? My daughter's in 2nd grade. She did her first experiment today, or Friday, in class. So you've learned about hypothesis ever since 2nd grade. So it's the part of the conditional following the word if. It's the first half of the sentence, if you will. Cool, Alex. Okay, and word number 3 is the conclusion. That's the other half of the sentence. The conclusion is a part of the conditional following the word then. So hypothesis, conclusion. For the notation part, the hypothesis is the P, and the conclusion is the Q. So that's the notation. P for number 2, Q for number 3. If 2 rays with the same endpoint form a line, then they are opposite rays. Now notice how I didn't make the if orange, and I didn't make the then green. So hypothesis does not include the word if, it's what's after the word if, and conclusion does not include the word then, it's what's after the word then. If you give a mouse a cookie, then he'll ask for a glass of milk. Okay, so hypothesis is you give that mouse a cookie. You do. Because that book would not have happened if you didn't give that mouse a cookie. The conclusion is he asks for a glass of milk. So it's like a cause and effect. If, then. We're about to take that conditional and we're about to manipulate that conditional a whole lot. So get ready to manipulate sentences. You're going to feel like we're in English class, not in geometry. Okay, number 3 is called converse. I want you to write it down. Converse. Sorry, number 4. Number 4. Number 4 is called converse. Write it down. Converse. What's a converse? The statement formed by exchanging the hypothesis and the conclusion. So the original is if P, then Q. The converse is if Q, You can write that down in the notation. If Q, arrow, P. That's converse. So an example is, if two lines are parallel, then they never intersect. The converse is, if two lines never intersect, then they are parallel. If you give a mouse a cookie, then he'll ask for a glass of milk. If a mouse asks for a glass of milk, then you gave him a cookie. You're switching. So I want you to think converse, reverse. Converse, reverse. Reverse, the hypothesis, and the conclusion. Converse, reverse. Oh, I'm not saying that they're parallel, and I'm not saying the sentences are the same. I'm not saying that it's true. We are not determining the validity of these statements. I'm just simply manipulating a sentence for now. I'm not deciding if they're true or false yet. Not deciding. Okay, next word. We're going to manipulate the sentence even more. Get ready. We are going to skip number 5. Did everyone hear me? We are skipping number 5. Everyone flip their paper over. Or go to the other paper if it's 2 separate pages. Because I don't like the order it goes in. Hate them. Number 6. Number 6, the word is already in the definition. Number 6, the word is negation. So write down number 6, the word is negation. The notation is a tilde. Negation means the opposite of the truth value, kind of like the opposite of your sentence. If I give a mouse a cookie, the negation of that would be if I do not give a mouse a cookie. Or what about if I do not eat breakfast? The negation of that would be if I do eat breakfast. You're changing the truth value of it. You are putting a not, pretty much. But if there's already a not there, then you are, a not makes a yes, right? Okay, let's go over it. Why do we need to know negation? We need to know that for word number 7, inverse. We needed to learn the word negation so that we could get to inverse. The inverse is the statement formed by negating the hypothesis and the conclusion. If not P, then not Q. This is your notation. If not P, then not Q. If two lines are not parallel, then they do intersect. Do you see how I took both of these? Two lines are parallel. Two lines are not parallel. They never intersect. They intersect. See how I'm changing the truth value of both of them? I'm changing the truth value of both of them. Let's do our easy example. If you give a mouse a cookie, then he'll ask for a glass of milk. If you do not give a mouse a cookie, then he will not ask for a glass of milk. So Haytham, yeah, the tilde does mean not in logic. That's what it means in logic. It's going to mean something else in our similarity unit. It means something else with congruency. Sometimes we reuse symbols. There's only so many out there, I guess. Okay, so here's the hardest one of them all. Get ready for the next one. First, I'm going to give you the notation, and then we'll talk about it. The next one is, if not Q, then not P. I'm telling you, we are manipulating these sentences. What did we do there? So this is the original. If P, then Q. What did we do for the next word on our vocab sheet? We did two things. We traded places, and we did not. Inverse plus converse. Very good, Sharon. We melded. We combined inverse and converse. It's like a hybrid. Hybrid inverse converse. Do you want to know what it's called? So that's the notation. If not Q, then not P. And it's called, a fancy word, contrapositive. So write it down. That is number 8. Contrapositive. Number 8. Contrapositive. If two lines are parallel, then they never intersect. If two lines intersect, then they are not parallel. If not Q, then not P. If you give a mouse a cookie, then he'll ask for a glass of milk. If a mouse does not ask for a glass of milk, then you did not give him a cookie. We're not saying if they're true or false. We're just rewriting the statements for now. Okay? Let's practice. Write down this sentence in your notes because I want you to have an example of one sentence written 4 ways. We're going to take the commercial that we watched. If you wait for the cable guy, then you get bored. So write that down somewhere in your notes. Okay, so look at your notes. Converse, reverse, converse, reverse. If you wait for the cable guy, then you get bored. Let's reverse. Let's trade places. It's like Freaky Friday. They trade places in that movie. I don't know if you've seen it. Okay, anyway. So, the converse, if you are bored, then you are waiting for the cable guy. Now, you're allowed to change the grammar a little bit. You don't have to just trade places because sometimes it won't make sense in English. So, you're allowed to change the grammar a little bit. Yours might not match mine perfectly. That's an example of a converse. If you wait for the cable guy, then you get bored. If you get bored, then you were waiting for the cable guy. So the inverse is not. So converse, reverse, inverse, not. If you are not waiting for the cable guy, then you do not get bored. So you don't rearrange anything. You don't rearrange anything. You just you negate and negate. Negate hypothesis, negate conclusion. If you do not wait for the cable guy, then you don't get bored. That's not always a true statement, but that's the statement. Okay, last one. This is when we reverse and negate. Reverse and negate. You ready? If you do not get bored, then you're not waiting for the cable guy, right? You are not bored, then you are not waiting for the cable guy. Are you like totally wondering why we're studying this in math class? Because this is English? This is reasoning, and math uses reasoning a lot. In math, it's important to be able to defend your answer with reasoning, with cause and effect. Okay? Fine. All right, go back to the front of your page because this is where I think this one fits. Number 5. Go back to number 5. The word is counterexample. Write down counterexample for number 5 in your notes. Counterexample. An example that shows a conjecture to be false. Do you ever love to prove your parents wrong? Do you ever love to find a flaw in their reasoning? Like, yeah, but, and you like find that like loophole? I bet y'all do. I bet y'all are pros at that. Counterexample is kind of like doing that. You're trying to find a flaw in the argument. And I bet y'all are much better at finding a flaw than you are at proving something is true. I bet you're better at proving it's false. So here's an example. Well, let me tell you this first. In a counterexample, you want to make the hypothesis true, and you want to make the conclusion false. There's no notation for counterexample, so I would put this in the notation column. Hypothesis true, conclusion false. I would write that in the notation column, because that's good to remember. So you want this sentence to sound like it's true, you're leading them on, and then boom, you catch them and you prove them wrong. So the beginning has to be true, the end needs to be false. So here's an example. If two lines do not intersect, then they are parallel. So I want an example where the beginning is true. I want two lines to not intersect. I want that to be true. But boom, I want them to not be parallel. And you got it, of course. It's our favorite counterexample in this unit. Skew lines is the counterexample. Notice how counterexample, is it a whole sentence? No, it's not a whole sentence. A lot of times the counterexample is one word or a phrase. Sometimes the counterexample is even a picture. It's not even a word. Draw a figure that would prove the conditional false. If two rays with the same endpoint travel in different directions, then they are opposite rays. That was on our warm-up today. So I would draw a picture of two rays going in different directions Yep, those are going in different directions. Check. Oh, but they're not opposite rays. I just drew a counterexample. All right, let's see if you are a counterexample. So I'm going to give some sentences, and I want you to raise your hand in the chat if you are a counterexample. Ready? If you are a Texan, then you were born in Houston. Let's go over it. So this is what I tried to stress to you guys. You need to make the hypothesis true. You're not trying to make the whole sentence false. You want half of it to be true so that, boom, you can prove it wrong. You want the hypothesis to be true and the conclusion to be false. You need to be a Texan, not a New Yorker, not a Californian. You need to be born in Texas, but not born in Houston. It's like I'm a counterexample because I was born and raised in Dallas. So I'm a Texan, born and raised, but I was not born in Houston. Sound right? Try the next one. If you're a girl, then you have blonde hair. Are boys allowed to raise their hand? No, because we don't want to prove the whole sentence wrong. We prove it wrong by starting off true and then, boom, being false in the end. So you raise your hand if you are a girl without blonde hair. Good job. Okay, next one. If you play video games, then you have an Xbox. So you would be raising your hand if you love video games, but you just don't even own an Xbox. Use a PlayStation. You play them on your cell phone. Play it on a PC. Yeah. If you have brown eyes, then your mom has brown eyes. Sometimes we have the same eye color as our parents. Sometimes we don't. So you would raise your hand if your eyes are brown, but your mom's eyes are green or blue or hazel. The last one. If you're in Geometry K, then you love math. Are any of y'all a counterexample to that? I hope not. Oh, don't hurt my feelings. So you would raise your hand if you are in Geometry K, which we all are, but you just don't love math, and that would make me so sad because math is the best subject ever. Okay.